Hi, good day everyone. This video is a continuation to my first video on data analysis using the free online version of Excel. So in this part 2, I'll be talking about box plots. So in the last video, we left off where we created the dashboard using two different charts for doing some data analysis using the free online version of Excel. Today, I will make a video on how to analyze a box plot because I often get asked a question that how do we interpret a box plot. So let's take a look at the same. So I've created one sheet where I have a simple data table of 3 companies' data of their salaries across 10 different employees. So this is company 1 data and the salaries for 10 employees. This is company 2 and company 3. So let's create a box plot for each. And a box plot is something which will easily help you understand any numerical distribution. So here we are going to understand the numerical distribution of salary, but it can be applied to any numerical distribution, and even for large quantities of data, it will quickly help you analyze that data without having to look at the data. Let's take a look at the same. Control Shift down, select this data, click on Insert. I'll go and insert the box plot. Alright, so let me keep it here and let me just change you can open this view by double clicking on the chart. So I'm changing this by keeping the company name as company 1. Okay. Let me go to the series and enable the data labels. Okay. Now let me do that for company 2. Again, I will go here, insert, and insert the box plot from here. Okay. Let me do the same. Let me go to the series and enable the data labels. And again, I'm doing all this in the free online version of Excel because I want everyone to be able to follow this video whether they have the paid subscription or the free version, and so everyone can learn these concepts using the free online version of Excel as well. This entire series will be focused on that. So I did it for company 3 as well. So now let me change the title again, chart title. Let me do this, company 2 and company 3. Let me enable the data labels for this chart as well. Now I'll just close this Format Explorer. Alright, let's just shift the 3 companies side by side, the box plots, right? So we can analyze them together. Alright, let me shift this one also here. Now quickly let us try to first understand the various elements of the box plot. Okay, so the lowest most horizontal line, this represents the minimum value of the data or the range. The upper horizontal line represents the highest value or the maximum value of the data. The upper part of the rectangle, the upper horizontal line represents the 75th percent mark of the data. The bottommost line of the rectangle represents the 25th percent mark of the data. The line in between the rectangle, which you can see, this represents the median, or also known as the 50th percent mark of the data. Okay, and the X mark represents the mean of the data. The lower line is also known as the first quartile. The line in between or the median is also known as the second quartile, and the upper line of the rectangle is also known as the third quartile of your data. So I just wanted to eliminate the technical terms and explain it very simply on what it means. Let's understand in even more simple terms on how to interpret this. This means that as this is the 25th percent mark of the data, that 25% of the employees are getting a salary below $1.75, right? From 0 to $1.75. Then you can see this is the 25th percent and 75th percent. So 50% of all the employees are getting a salary in the range of $1.75 to $4.25, and 75% from the third quartile onwards of the employees. So this is 75%. So 25% of the employees are getting a salary of greater than $4.25. So that is how you interpret, right? If you imagine an imaginary curve over here, you can see this has a long right side tail. So the data is skewed to the right, okay, where the mean is greater than the median, which also means that in this range most of the employees are in the lower range of the salary as compared to the maximum and minimum values. Now let's take a look at that for company 2. In company 2, we can see the range is similar. Lowest is 1, highest is $1 more, 9, but look at the distribution. Here, the first quartile is at 4.75, the median is at 6.5, and the third quartile is at 7.5. So here what it means that 25% of the employees are getting salary below 4.75, that is the first quartile. 25% to 75%, that means the middle, that is 50% of the entire distribution is getting a salary between the range of $4.75 to $7.5. So you can immediately see that the 50% of the population of this numerical distribution is getting a salary in a higher range as compared to this, right? And 25% of the employees are getting a salary more than $7.5. Immediately you can see that in this case the median is greater than the mean. If you imagine a curve here, it shows that it is skewed to the left. It has a long left side tail, and compared to this range, the employees are being paid at a slightly higher salary value. Now let us take a look at this. So this looks perfectly symmetrical, right? So this is also called as a normal distribution. It looks symmetrical because the mean and the median coincide. You can see all the numbers are equally distributed. Minimum is $1, maximum is $10. First quartile is 2.75, third quartile is 8.25. 50% of this distribution, the employees are getting a salary between 2.75 and 8.25. And you can see the reason for this, because in this case, I have perfectly distributed the salary across all the employees, right? One employee is getting 1, second employee is getting 2, 3, 4, right up to 10, just to show that how a normal distribution looks like. So by analyzing a box plot, you can quickly tell how your data is distributed, okay? And you can quickly understand any numerical distribution, and you can take decisions and business outcomes on the data, right? For example, if you need to know that if you need to hire new employees, should you pay them the median or the mean salary, or how that will impact your distribution going forward if you give employees higher salaries, or if you give employees more than the maximum, then they will be called as outliers. So all these questions you can answer for yourself, right? So this is a very, very important tool. This can also be analyzed using a histogram. Numerical distributions can be analyzed using histogram. If you want me to make a video on that, do let me know. If you like my video, please do like and subscribe to my channel and like my video, and leave any comments on any other videos that you want me to make. I will also leave a link to the part 1 of the series, and so you can take a look at that if you have not seen that already. Okay, have a good day, and do wait for more parts in the series. Thank you.